All right, welcome everybody. My name is Matt Hardy. I'm the Program Director for Planning and Performance Management at AASHTO. I want to welcome everybody to the third of 6 Transportation Asset Management webinars that are taking place sort of this spring, summer, and fall, being sponsored by the Federal Highway Administration Transportation Asset Management Expert Task Group, the TAM ETG. Katie, in a few minutes, is going to talk a little bit more about what the TAM ETG is. The topic of today's webinar is Network Lifecycle Analysis, Part 1, Introduction and Overview. We're going to have a Part 2 of this webinar, also sponsored by the TAM ETG on September 9th, 2015, again from 2 o'clock to 3:30 in the afternoon Eastern Time. And we do have a few other webinars planned as well on cross-asset allocation and then integrating asset management into an agency's sort of decision-making planning processes. If you're interested in these webinars, if you're interested in any of the other webinars that we have done, which we have recorded, you can go to tam.transportation.org, click on webinars, and you can download, you can view previous webinars, you can download all the presentations. Also at the website tam.transportation.org, we have recently updated that to be more of a overall TAM information portal, access portal to lots of different TAM asset management information. So it's not just about webinars, but there are lots of resources there as well. It includes a link to a publication or a resource that was just completed through INSHRP, sponsored by AASHTO, the Subcommittee on Asset Management templates. So if your agency organization is interested in putting together a transportation asset management template, we have a tool there designed to help you. If you want to look at good examples of asset management templates elsewhere in the world, in the US, you can do that. If you want to download a template that you can use and sort of customize yourself, you can do that. So I think it's a fairly robust tool that people can use. But again, you can find all of that at tam.transportation.org. I would encourage you to go there. And again, you can register for other webinars being sponsored by the Asset Management ETG, along with other sort of non-TAM ETG webinars being sponsored by AASHTO and FHWA. So I think a great resource for everybody, sort of a one-stop shop for asset management. I also want to plug a LinkedIn group called simply Transportation Asset Management. So if you go onto LinkedIn and you search for the group Transportation Asset Management, you can join it if you're from a public organization. Matt Haubrick of the Iowa DOT has sort of set this up, and if you're a LinkedIn user, you want to connect with other LinkedIn users on the subject of asset management, you can do it there. Finally, if you have any questions for the presenters during today's webinar, please use the GoToWebinar Q&A feature. You can raise your hand towards the end of it, but we're going to be sort of doing the Q&A via the question and answer functionality of the GoToWebinar service. It's worked fairly well in the past. I also want to mention, I almost forgot, they have a new functionality. A lot of people ask us, the first question that we get is, how can we download these presentations that the presenters are presenting? And if you look on the navigation panel there for GoToWebinar, there's a new section called Handouts, and I have uploaded the 4 presentations, including this one, which is more of a structure, sort of table of contents one that we're using, and then the 3 presentations. The final draft of most of these, they might vary or have been updated a little bit, but near final versions. So you can download those directly right now to your computer, and if you want to take notes on them, you're more than welcome to. We will also provide these as PDFs and stuff at the tam.transportation.org website, where we archive all of these webinars. So again, lots of resources for you, trying to make it as accessible as possible. In terms of phone logistics, everybody has entered into what we call lecture mode. So all the audience or the attendees can only listen. Again, you ask your questions via the question and answer functionality, and all of the presenters are in are not in lecture mode. So the presenters have sort of, we've gone through this, but I just want to make sure that the audience members knows that we're not going to be calling on you verbally, just because that would be a little too cumbersome, and we get a lot of feedback and stuff with that. But the webinars have gone great in the past, and I assume it will. I'm confident that today's webinar will go just as well. So with that, again, thank you for attending. I hope you find these useful. If you have any feedback in terms of future topics, specific people to include in these presentations, we'd love to hear from you. We believe these webinars are valuable of getting the word out about asset management and sort of promoting best practices, that sort of thing. So again, if there's something you want to hear more about, let us know, because we're always sort of thinking, brainstorming about what are some good webinar topics. So with that, I'm going to turn it over to Katie Zimmerman, who's going to be our overall moderator for today and the MC. So with that, Katie, all yours.
Thanks very much, Matt. I'd also like to welcome everyone to our webinar today that's sponsored by the FHWA's Asset Management Expert Task Group. FHWA and AASHTO have been hosting these types of webinars to provide an opportunity to really connect with the asset management community and to bring people together around a series of important topics. And they've been doing this since 2012. I think that sharing this type of information and sharing the knowledge and experience that practitioners have is a critical way of advancing asset management practices. And as Matt mentioned earlier, you can see all of the webinars that have been held previously using the website that's shown here, or you can just visit tam.transportation.org and click on webinars, and that will also get you the information. We have some great speakers today, and I'm confident that this will be a very informative webinar. We have Nastran Sadatman from the FHWA's Office of Asset Management, Pavements and Construction, who's going to start things off with some opening remarks. This will be followed by 3 technical presentations. The first one focusing on life cycle costing for pavements by Kirby Becker of the Minnesota DOT. And the second presentation is going to focus on life cycle cost analysis in bridge management, and that's going to be given by Paul Thompson, a consultant. These are going to be followed by a presentation on the link between financial plans and life cycle costing, and that'll be presented by Shobna Varma from Star ISIS Corporation. And then, as Matt mentioned, if you go ahead and enter questions in the box on the screen, we'll have time at the end for some questions and answers for any of the speakers. Before we get started, I do want to quickly recognize the contributions of the FHWA's Asset Management Expert Task Group, which was established several years ago to serve as a forum to discuss some of the changes in the way highway agencies are managing assets. The structure and the membership of the TAM ETG were intentionally designed to ensure interaction with some of the key AASHTO and TRB committees. The TAM ETG has been active in a number of different types of activities. They've been identifying strategies for advancing asset management practice and influencing the change within state DOTs. They've provided some input to FHWA, AASHTO, and TRB regarding some of the direction, definitions, processes, and tools that are needed to help implement asset management. And they've also developed an implementation plan for communicating the work of the Asset Management ETG to the transportation community. The in-person meetings of the TAM ETG are open to the public, and the next meeting is planned for October in St. Paul, Minnesota. And you can contact Matt Hardy if you're interested in attending that and listening to the conversation. The membership of the TAM ETG includes individuals from state DOTs, metropolitan planning organizations, or MPOs, and academia, as well as individuals representing Australia and Canada. There are also liaisons that have been invited to participate from AASHTO, FHWA, TRB, and also AMPO, the Association of MPOs, as shown on the slide. So more information on the TAM ETG can certainly be accessed on the FHWA website if you go there. The sponsorship of the webinars is just one of our activities of the TAM ETG. And as Matt mentioned, this is the third in the series of 6 that are specifically hosted by this group. We've previously had 2 webinars, one that was on target setting and the asset management plan, and the second one was on TAM 101 for MPOs. In the future, we're going to have the second part of the network lifecycle cost analysis in September. We'll have one on optimization and cross-asset allocation in November. And in January, we'll have one on integrating asset management into agency processes. And I believe Matt has said in previous webinars that the date of the January one might actually change because that's right in the middle of TRV week. So again, if you want more information on the webinar series or to register, just visit tam.transportation.org and click on webinars. I also wanted to let everyone know that a new pooled fund has been announced by the Iowa DOT to support the next 3 biennial asset management conferences. And information about the pooled fund is available using the link that's shown on the slide. The important thing to note is that it's solicitation 1401. The first of the 3 conferences that will be supported under this pooled fund is scheduled for Monday and Tuesday, July 10th and 11th, 2016 in Minneapolis, Minnesota. There will also be workshops and an AASHTO peer exchange planned immediately prior to the start of the conference. So please mark your calendars and consider joining the pooled fund. I know the last conference was held in 2014 in Miami, and it was very well attended and very well received, and we expect the next conference to be another big success. So remember, if you have any questions for any of the presenters today, please submit your comments or questions using the question and answer feature. And with that, I'll turn it over to Nastran Sadatman from the FHWA Office of Asset Management, Pavements, and Construction for some opening remarks.
Thank you, Katie. And good afternoon, everybody, and good morning to those of you who are in a different time zone. We all know that an asset management framework includes several key elements. These key elements have been included in MAP 21, in the AASHTO guide, also in other publications. These include asset inventory, condition, performance targets, life cycle cost analysis, risk analysis, and a financial plan. All these collectively should lead to development of investment strategies. As Matt and Katie mentioned, today's webinar focuses on the life cycle cost analysis. To clarify, we are not talking about project level life cycle cost analysis. We are focused on network level analysis. Also, to clarify the term life cycle cost analysis, and the terms life cycle planning and also whole life costs are sometimes used instead of life cycle cost analysis. We perform network level life cycle cost analysis to achieve some important objectives, such as determining the level of funding needed to manage an asset class and in a cost-effective way for its whole life, or to predict what type of work or funding is needed over a given period of time, such as the next 10 years, or to examine various options that we may have to manage an asset class during its life in order to determine the minimal practical cost. So we are not just looking for an approach that gives us the minimum cost. We are also looking into an approach that is practical too. I want to thank you for joining this webinar, and please share the concept of life cycle planning or whole life costing or network level life cycle cost analysis with those who in one way or another are involved with managing our highway infrastructure assets. With that, I'm turning it over to Katie.
All right, thanks very much. Our first speaker is Kirby Becker, and with the Minnesota DOT. He is with the Office of Transportation System Management, which is in the Modal Planning and Program Management Division at the DOT. Kirby was heavily involved in the development of the Minnesota DOT Asset Management Plan, and he's going to share with us his experiences in conducting the life cycle cost analysis for pavement. So Kirby, go ahead and take it away.
All right, thanks, Katie. And before I get started, I would like to say thank you to the TAM, ETG, AASHTO, and FHWA for allowing MnDOT to present today on MnDOT's pavement lifecycle costing and the analysis that took place as part of the Transportation Asset Management Plan. Hopefully everybody that's participating today will walk away with enough nuggets to help you move forward if you're thinking about lifecycle costing for pavements. With that, I'll get started. So my presentation framework for today is really three pieces. The first is to provide you with a brief overview, talking specifically about the development process, the components of the asset management plan, and the assets that were analyzed during the first TAMP, as well as the second TAMP that we have going. Two is to really, of course, highlight MnDOT's TAMP pavement lifecycle costs, but specifically looking at these four elements: the purpose for including the lifecycle cost and the lifecycle cost analysis in the TAMP, the process that we used, some of the inputs and assumptions, and then finish off by focusing on several strategies that we developed and the results after we modeled the strategies and the inputs and assumptions. And then last, the third element that I'd like to highlight for just a few minutes at the end of my presentation is something of a recommendation that came out of the Transportation Asset Management Plan, and that was to collect better information and better data on maintenance activities that are occurring on our roadways specific to labor, equipment, and materials to better refine the network analysis that was done in the TAMP. So Nastran kind of briefly mentioned the asset management plan in her opening remarks, but I'd like to just provide a brief overview. There's only a couple of slides here, and I apologize for those that have been involved in a previous ETG webinar where I presented, because the first few slides here are going to be a little bit redundant, but I did this more so for those folks that haven't been involved, and this is your first webinar. So Minnesota, along with Louisiana and New York, were part of a FHWA pilot project to develop a transportation asset management plan, specifically a risk-based asset management plan, to meet the requirements of MAP 21. And the idea was to have asset management plans that the other states could use as a guide moving forward to meet these MAP 21 requirements. Nastran had mentioned some of these elements already, but these are the primary components within MnDOT's Transportation Asset Management Plan. And these elements pretty much parallel what's identified in MAP 21. But for today's discussion, I'm specifically going to highlight the third bullet and focus on the pavement lifecycle cost analysis. I do want to point out that as part of our first asset management plan, MAP 21 specifically says that you need to include, for states that are doing this, NHS bridges and pavements. We decided to include our entire state system for pavements and bridges, as well as 4 other assets, and they're shown here. Right now, the Transportation Asset Management Plan was finished last summer, and the rules came out, and we're kind of, it's in a final draft format, and we're waiting for the rules to be final, to come through to see if there are any needed changes, and then we'll adopt it and make it final after we make any needed changes, if any. But asset management is elevated to the highest level within the agency, and we have received direction from senior leadership that we want to continue with this asset management planning initiative, and so we've moved on to completing a TAMP 2 for the assets that you see here, with hopes to wrap that up by the end of this year. So let's get into the second piece of the presentation today, and that's focusing on the TAMP pavement lifecycle costing. The primary purpose is really, there's three of them. One, to convey strategies for managing an asset effectively using preservation activities. That's bullet number 1. 2 is to quantify future maintenance requirements that are associated with capital improvements and expansion projects. And that's really bullet number 2. And 3 is to determine whether replacement decisions that are being made in a timely manner and whether an agency is capitalizing on preventative maintenance opportunities. LCCA, or Life Cycle Cost Analysis in the TAM, should answer the question, which investments made today are most cost-effective in the long term to keep assets at an acceptable level of service? And that's really the most important question to answer as you move forward with life cycle costing. To better help tell the story in the beginning of the process, we put together this life cycle cost iceberg to illustrate the difference between initial capital expenditures and future preservation activities and expenditures. For policymakers, legislators, and the general public, it's important to understand life cycle cost impacts for the existing system, but even more so for considerations of system expansion. For purposes of MnDOT's TAM payment life cycle cost analysis, only the initial capital and preservation treatments over the life cycle analysis period were included in the analysis. Operational costs such as snow and ice removal and pothole patching, to give a few examples, were not actually included in the LCCA. The process that was used, initially we set up a pavement technical work group, and that technical work group comprised primarily of staff from our pavement office as well as district maintenance staff, and the district maintenance staff were involved to really help bridge that gap between the capital investments that are made through our materials office or our highway pavement management application and what's actually happening out there in terms of the minor and major preventative maintenance activities in between the mill and overlays or the reconstructs. The technical work group provided information such as pavement deterioration, typical and desired capital and preservation cycles, treatments and costs, inspection costs, and various other inputs and assumptions. And it was all this information together that was critical to being able to build representative models and strategies for pavements. There's a couple of tables here that were taken out of pre-assignments that we sent out to the technical work group for pavements, and we asked them to identify the preventative maintenance, the minor rehabilitation, the major rehab, and the reconstruction. You can see what the treatments that are occurring, at what condition level, what's the most likely condition after treatment, and the costs associated with those treatments. In terms of the inputs and assumptions, there are roughly a half dozen or so inputs and assumptions for pavements that were collected throughout working with the technical work group. One I'd like to focus on is the 70-year analysis period. That period was selected to capture one major rehab treatment beyond a desired life cycle cost approach, where reconstruction occurs at approximately 50 years. And that's important, and I'll show you that in the next couple of slides. 2, several treatment cycles and costs were used to compute life cycle costs for flexible and rigid pavements, and then combined into one composite value based on weighted averages of the percent of rigid and flexible pavements at the network level. And you can see that in bullet 4, specifically the sub-bullet under bullet 4. Other things that were important, I guess, in the discussion of pavements for the LCCA was inspection and operational expenditures. They were investigated but not included in the modeling. And then lastly, routine and reactive maintenance costs were included in the LCCA model, and I'll talk about that on the next slide. So as far as routine and reactive maintenance inputs and assumptions, historical expenditures on routine and reactive maintenance were collected and incorporated into the models based on 2012 data collected from MnDOT's Metro District here in the Twin Cities metro area. We know that in 2012 we spent $1.4 million on maintenance activities for pavements. That number could not specifically be tied to condition level, good, fair, or poor, but we do know that that money was spent on 482 lane miles of pavements, of which are broken down by condition in the fourth bullet on this slide. So what we did is the approach that we took was we used a weighting factor and applied that to the maintenance cost. 0.8 for good, 1.2 for fair, 1.8 for poor, which equates to those numbers per lane mile that would be spent of that 1.4 million. And those numbers were incorporated into the pavement model. MnDOT's TAM life cycle cost analysis compares a worst first, a typical, and a desired approach to pavements. And the mill and overlay strategy, which I'll show you on the next couple of slides, represents MnDOT's typical life cycle cost approach, while the full depth reclamation or reconstruction represents MnDOT's desired life cycle approach. The graph on this slide illustrates what happens under each strategy in terms of pavement condition associated with minor and major preservation treatments. The smaller dips indicate minor preservation treatments such as crack and surface treatments or activities, and the median dips indicate major preservation treatments such as mill and overlays. The large dips, as seen in between years 20 and 30 for worst first, and at year 50, and also in between 50 and or after 60 for the dashed red line and the blue lines, which is the typical and the desired, they really indicate the reconstruction or the full depth reclamation activities that are occurring with desired and typical. So I mentioned that we put together allowing or collecting the information on the inputs and assumptions and all of the data that we collect working with the technical work group. We were able to develop these strategies and understand kind of the approach that the agency takes. And as I mentioned on the previous slide, MnDOT is at a network level taking a mill and overlay strategy for flexible pavements system-wide. And of course, this is not occurring on a project-by-project level, but at a system level or a network level, this is our typical approach. Using the information, we were able to put together this strategy, and this table shows that the typical strategy shows that reconstruction is occurring around 70 years. Now the FDR, or the full depth reclamation and reconstruction strategy, as I mentioned earlier, is our desired approach that came out of the modeling. And I guess in conclusion to this strategy, or as a result of the TAM pavement lifecycle cost analysis, we are now identifying more pavement projects that are eligible for upscoping to be reconstructed that are beyond that 50 years if you looked at the typical approach to be more in line with this desired approach that you see in the table on this slide. The last thing that I'd like to point out for the life cycle cost analysis as part of MnDOT's TAMP are the results. And rather than getting into the specifics of each of these bar charts, what this means, to put the numbers into perspective, is essentially the agency's current policy saves approximately $17 billion when you compare it to a worst first strategy. And so that's really looking at the red lines, or the red bar lines, and comparing it to the blue lines, the typical. And that's really over the entire inventory over the analysis period. But if we were to take a desired approach or a desired strategy and compare that to typically what we're doing, that would amount to a savings of approximately $600 million over currently what we're doing. And that's, again, over the entire inventory over the analysis period. So as a result, the TAMP LCCA predictive models that incorporate deterioration and treatment costs and effectiveness allow MnDOT to better or more reliably forecast long-term policy outcomes and program development decisions. And I guess it's allowed us to do a better job at managing our payments. The last thing that I'd mentioned that I was going to just briefly highlight is this idea or the recommendation that came out of the asset management plan to collect better information on maintenance activities that are occurring out on the system so that we could better refine the TAM lifecycle analysis. And so I'd like to just highlight a couple of slides on what we're actually doing or what was started as a result of the TAM. And we have an agency goal. I'll call it an agency goal or a wildly important goal as stated by the agency. And phase one is really to determine how much labor, equipment, and materials, or LEM, is being spent on payments by payment condition. Now, what we're doing is we've built a business intelligence tool where we're going out there and the materials or the maintenance staff are going out into the field, and when the activity is being performed, they're entering that into RCA, which is our financial tracking software for work orders, and we're linking that information to records within our highway pavement management application. And this graph is not intended for you to look at each one of these records, but essentially the shaded cells that are on the left, or the half dozen rows on the left, is information that comes out of our pavement van that's going out and collecting the condition data. The information on the right is the labor, equipment, and materials that is actually being linked to each of the M records within our HPMA software, our highway pavement management application. And this is allowing us to better understand where the maintenance dollars are being spent by surface rating. And you can see this on this slide, that this chart shows the relevant source type expenditures in relation to surface rating, which is the x-axis. The trend shows decreasing cost per mile associated with increasing pavement condition, which is, I guess, probably what we would think. But the two preliminary takeaways are that there's a lot of work being done on pavements within the mid-3 for ride quality index. And then secondly, there's just disproportionately low cost per mile on very poor roads, which may reflect a needed change in business practice based on the life cycle cost analysis that was performed as part of the TAM. So what this means is we're going to take all this information that we're collected, and we only have 1 year of data, and we're going to continue to collect this year after year after year and refine the pavement life cycle analysis from the asset management plan. But that information is going to feed directly into the blue squares or the blue cells that you see highlighted in here. And having that information will allow us to refine those minor preservations treatment as part of that life cycle cost analysis. So thank you. I appreciate your guys' time, and hopefully I've given you enough information to help you move forward with life cycle cost analysis for payments.
Fantastic. Thanks very much, Kirby. There was a question that came in, and perhaps you can try to tackle that while I'm pulling up Paul's presentation. The question is, has MnDOT been able to apply your first TAMP in the field? In other words, are the maintenance forces using it so it's more of a preventive approach versus a worse first approach?
We have been able to apply it in the field, and that activity beyond the asset management plan is allowing us to do that. I guess I should note that MnDOT has not taken a worse first approach in any of our segments of pavements or miles of pavements that are out there, and that's if you went back to the bar charts. And typically at a system level, we're taking a typical approach, which is a mill and overlay strategy. And I think there are several districts that are actually taking the information from the TAMP and better applying it to the age and kind of that historical life cycle cost strategy within their district. So yeah, I think we are doing a better job identifying when those maintenance activities based on the strategies that were developed as part of the TAMP.
Excellent. All right. Thanks very much. So now that we've had a little background in applying life cycle costing for pavements, we're going to switch gears, and Paul Thompson is a consultant who is very well recognized for his expertise in bridge management and engineering risk management. And Paul has worked on the development of a number of bridge management programs and has led many multi-year research projects and programs to develop some of the engineering economic tools and risk management processes that are needed to support asset management. Today, Paul is going to talk to us about conducting a life cycle cost analysis for bridges. So Paul, I'll turn it over to you.
Okay, thanks very much, Katie. A lot of what I'll be talking about with bridges is actually pretty similar to what you have to do for a life cycle cost analysis for pavements. So I'll be picking up where Kirby left off and getting into a little more of the technical aspects of life cycle cost analysis for bridges. There are several purposes for doing a life cycle cost analysis for bridges. One is to establish the benefit of doing bridge preservation. If you look at the little graph at the bottom of your screen, you can see that it kind of demonstrates what we're trying to do with life cycle cost analysis is to use a preservation strategy with maintenance and different kinds of capital projects that prolong the life of a bridge and thereby postpone the need to spend a lot of money on bridge replacement. If you're successful in doing that, then hopefully over the long term you'll be spending less money because you'll be spending less on these expensive replacement projects. Some other purposes that are also related to that are to establish a value for different kinds of protective systems, particularly work on maintaining paint and deck wearing surfaces and possibly cathodic protection systems that you use on bridges to try to postpone deterioration. You want to look at the trade-off between investments you might make today and some you might make later. Obviously, you would like to postpone costs, and money is scarce, so you have to postpone some costs, and so you'd like to find out which costs can you put off with the least impact on the public and the least impact on long-term costs. So we're trying to keep costs at a minimum over the long term. There are several basic ingredients that go into a life cycle cost analysis. There's a deterioration model to forecast how quickly different parts of a bridge will deteriorate. There are cost models to estimate the costs of different kinds of treatments that you would apply to a bridge to either preserve or improve the condition of different elements of a bridge. And then there are models of the effectiveness, just what does the treatment do in order to improve condition and how effective is it at improving condition. All of those models feed into what's called a life cycle activity profile, which is basically a type of plan for the whole future of a bridge to plan out over time just what kinds of work might be done at different places in a bridge's life cycle. And of course, the part of that that you care most about is the part that involves spending money now or in the near future, but those decisions also depend on how long you can postpone future costs. So we're trying to analyze just what that kind of long-term effect could be. This will give you some idea of the trade-off between the scope of work that you might undertake now and the timing. If you do certain work now, perhaps you can postpone future work till much later. And there are also performance trade-offs related to the amount of money you put in now versus the condition of bridges in the near future and the far future. So we would like to use the analysis to shed light on how money going into the system results in good condition coming out of the system. Just to give you a quick, pretty simplified quantitative example of a life cycle activity profile, here we may be looking at two alternative futures for a bridge over a 50-year period. Alternative number one involves doing preventive maintenance, and alternative number two involves not doing anything right now, but then replacing a bridge relatively soon in 12 years. Under the preventive maintenance strategy, perhaps we can get at least 20 additional years out of the bridge and maybe postpone that replacement out to the 35th year. One of the key inputs into a life cycle cost analysis is a discount rate. So here I'm comparing a discount rate of 95% versus a rate of 90%, just to see what difference it makes in the analysis. And you can see it does make a difference as far as which of the alternatives is going to be the least expensive over the long term. At a 95% discounted discount rate, the alternative number one turns out to be $799,000 at a 95% discount rate over the long term versus only $464,000 at a 90% discount rate. And that's because you're giving less weight to that future replacement cost. If you look at alternative two, you can see that the costs are a little different, and in fact, under the 95% discount rate, turns out that alternative number one at $799 for a 95% discount rate is actually less expensive than alternative two at the 95% discount rate. If your discount rate was only 90%, you would find that alternative two is actually the less expensive in the long term because you're at the 90% discount rate, you're giving less weight to those future costs. So that affects how you would make decisions. Now, this is kind of a bridge level look at it, but for transportation asset management, a lot of times we want to look at this at the network level, just the combined effect of all of these decisions over a whole inventory. And one of the main implications of this kind of comparison is how you would set priorities. So with projects like the one that you're looking at here, if you're using a 95% discount rate, which is actually more typical for what state DOTs would use, you might choose alternative one in this case for projects that are similar to this one with a higher discount rate. With more discounting, you would choose alternative two. You actually give more weight to preservation. Now, one of the first ingredients to do a life cycle cost analysis is a deterioration model. Now, most of the states have a bridge management system called Pontus, which is used for doing life cycle cost analysis. You can see an example here of just the kind of language that is used in describing bridge conditions, in this case for painted steel girders. The states are currently in the process of making a transition to a new version of the condition state language, and ASHTO is in the process of developing a new version of its bridge management software to reflect that new condition state language. So you're looking here at the old version, which is what most of the states are still using today, but soon that transition will move over to a new set of definitions. But the concepts that I'm illustrating here are the same either way. So if you're looking at a set of data, say, and you're looking at your Pontus database at your past inspections, the only thing you see in your inventory is you see an inspection, say, in 2005 and another inspection, say, that happened 2 years later in 2007. Your bridge database doesn't tell you what happened in between those two sets of data. So when you're trying to estimate a deterioration model, you're trying to figure out quantitatively what might have happened between those two data points. The blue lines illustrate deterioration paths, which are just different ways that condition may have deteriorated between 2005 and 2007 if nothing was done to preserve the bridge. The red lines, on the other hand, indicate improvements that may have been made. So some maintenance may have been done between 2005 and 2007. Now, of course, ideally, what you'd like to have, and what Kirby described MnDOT is trying to do, is to have good records as to what actually happened between 2005 and 2007 that affected the condition of the bridge. Most of the states do not have very good records on that right now, and one of the impacts of asset management in general is the need, as Kirby described, to improve that record keeping so you do know what happened. But a lot of times what we have to do today is make some assumptions, such as if condition improved, then maintenance must have been done. And that's a pretty coarse way of doing the analysis, but it does work, and a number of states have done it. So it's definitely better than nothing to just make some assumptions so you can get some broad numbers as to how quickly things deteriorate. But we're just trying to separate the blue lines from the red ones so you can figure out the rate of deterioration that happens when no maintenance is done on bridges. The way we quantify that deterioration rate is something called a Markov model, or Markovian model. If you look at bridge management systems around the world, this is pretty much the only way anyone is doing it at the network level. And the reason for that is it's pretty much the simplest possible deterioration model you can have with the types of inspection data that agencies are using. You have in the columns in this table, in this example, 5 condition states that may have resulted after a 2-year period between inspections. And the rows are the starting condition states at the previous inspection, start of the 2-year interval. And the numbers in the middle of the table are percentages. Those are the probabilities of making a transition from each state to another state. So if you look at the probability from condition state 1, which is the best condition, to remain in condition state 1 2 years later, that's a 93.4% probability. In other words, out of 100 bridges, 93% of them stayed in the same condition from one inspection to the next. So that is a very typical deterioration rate for steel girders, for example, and 6% deteriorated. And you can also look at other pairs of condition states. In a deterioration model, you don't see any conditions improve. So the lower left part of this table is generally always filled with zeros. But the upper right may have non-zero numbers for possibility of deteriorating from one condition to a worse condition. So we'd like to be able to develop models like that, and there are some pretty good methods to do that. The first one, and this is what most of the states have been using with their Pontus system, is expert judgment. The great thing about expert judgment is it's easy and cheap. The bad thing about expert judgment is what we found from our research is it doesn't agree with real inspection results as well as we would like. As I said, it's better than nothing, but you would like to be able to improve on it, and I'll describe what the differences are in a moment. Statistical modeling is the other approach, and that is definitely the recommended approach, and a number of states have started to do this because most of the states that are doing element inspection have been doing it for quite a few years now and have pretty large data sets. I did an analysis a couple of years ago in Florida where they had more than 1 million records of element inspection data that we could use for deterioration models. That's a lot of data. You can produce really good models if you have 1 million data points in your database. And that's not uncommon at all. Florida's inventory is just an average size inventory for bridge deterioration modeling. So We found with statistical modeling, you need about 500 inspection pairs. An inspection pair is just an inspection at one point in time and then another inspection 2 years later. So that's a pair of inspections, and you need 500 of them. So if you've been doing bridge inspections for say 5 cycles, then you need 100 bridges containing a particular element in order to have enough to do a deterioration model. So it doesn't really take that much when you're looking at a statewide inventory of bridges. In the Florida analysis, and Virginia and a couple other states have done this, there are spreadsheet-based models that you can use to develop these. AASHTOWare's new software will have some built-in techniques to develop these, which help to make it easier to develop these models. The graph just shows a comparison from the Florida data of several different elements and how quickly we found the deterioration to be looking at the actual bridges in the inventory. And as you might expect, joint seals deteriorate quickly. That's the red line in the graph. The coated metal rails are kind of in the middle. Concrete superstructure elements tend to deteriorate more slowly. Bridge decks deteriorate very quickly at first, and then they level off over time in the Florida inventory. So you see some distinctive behavior of different kinds of bridge elements when you look at this information a lot. We found that the statistical analysis makes a big difference. When we compared our statistical results against what an expert panel had come up with, we found that the expert panel had actually underestimated transition times by a factor of almost 2. And the reason is when you get a panel of experienced experts sitting around a table thinking about bridges in the past and how quickly they deteriorated, they tend to remember things that change more easily than things that stay the same. And so they tend to remember deteriorating bridges more readily, and that causes them to underestimate transition times. So that's something to be aware of, that your transition times may be underestimated if you're using expert judgment-based models. And that's one good reason to do a statistical analysis instead. Now, in bridge management systems, you also need cost models to do a life cycle cost analysis. There are direct costs of labor, materials, and equipment, and also contract pay items if you're doing contract work. And there also are indirect costs, which are also important. And some types of projects, especially preservation projects, the maintenance of traffic and mobilization could be as much as half the project or even more. So you need to include that because those are all costs that also are affected by a decision to do preservation or not do preservation. So it's important to include all of those things, and as Kirby described for you, it takes some effort to get your system set up so you're really capturing good data, but it's a garbage in, garbage out process, so you need to have good data going in order to feel confident with the conclusions that come out. In order to develop cost models, one of the things that we've done in a few states is to actually take different elements and group them together into categories that we can more easily map onto maintenance management system activity codes. So this worked pretty well. In this example is from Florida. We were able to group elements in this way and get a reasonably good match for more than half the elements between the maintenance activity codes and the Pontus action codes. And so from that information, we were able to develop estimates of unit costs and also effectiveness of different kinds of actions. So that we had some good quantitative information then to use in the analysis. Incidentally, we found that if you sit a group of experts around a table to estimate unit costs, we found that the experts tend to underestimate the unit costs, that things actually cost more than what they are estimating. And action effectiveness can be done using a similar process of statistical analysis using maintenance activity by grouping elements into categories, so you can match the bridge management system actions to your maintenance activity codes. So that was what we did. This is an example again from Florida. We did a statistical analysis of condition before and after different actions that had been taken during the period when we had element level data, and we found that actually the expert panel had underestimated the effectiveness of actions. That conditions actually improved more than what the panel had estimated between the before and after inspections when an action was taken. So that was a good thing. We found that the deterioration models tended to overestimate needs because they underestimated how quickly things deteriorate, but the costs and effectiveness worked the other way around. And so in the end, we ended up with needs estimates that were reasonably good, although the data going in were not so good. But this is something that in the future now, since we have statistically based models, we're able to improve on this and have more accurate needs estimates. Once you get all this information together, there's a number of things you can do with it. If you're familiar with NCHRP Report 590, you'll find in there some pretty detailed examples of how to do a trade-off analysis. And there's some spreadsheet software you can try out that shows an example of how to do that with Pontus data. It basically shows you how you can lay out a grid of different scoping approaches, such as do nothing, maintenance, repair, rehabilitation, or replacement. And then you can also look at the effect of timing, whether you do the action this year or next year or wait 20 years. And you can draw graphs of what the costs look like, what the condition looks like, and what the life cycle cost is going to be over the long term. So that will help you to figure out both what is the best scope and the best timing for a given bridge. So what combinations give you the lowest cost, and how much do you lose if you have to delay work because you don't have money to do all the best treatment selections right now. Then there's also a network level aspect of this, which is important for your transportation asset management plan. So this graph is an example from one state that is putting together a TAM plan where we basically just want to look at the performance measure, percent in poor condition, using the NPRM performance measure, and the long-term cost, in this case over 12 years, including inflation. So basically looking at a fiscal scenario or a whole set of fiscal scenarios and how those might affect the condition of the bridge inventory. What this graph shows and what you'll typically see is that a condition, of course, will get worse if you put less money into the program. The more money you put into the program, the better the condition will be. That, of course, is obviously what you would expect. And but the life cycle cost analysis and the investment analysis will help you to figure out quantitatively what that condition is likely to be at some time in the future. So this is a really useful analysis for setting targets. For your TAM plan, you need to set a 10-year target, and you can use this kind of analysis to figure out just what kind of condition is achievable after 10 years under a given fiscal scenario. And of course, Shobna will describe in the next presentation just how to get at these fiscal scenarios to figure out what is reasonable to decide how much money will go into this analysis, because then that will help you figure out how much condition can come out of the analysis. And the fundamental life cycle cost trade-off, of course, we're trying to get at is to find the happy medium. You're not doing too much maintenance, not doing too little maintenance. There is a point where you're optimizing your expenditure, keeping the long-term cost at a minimum over the long term. Typically, that keeps bridge elements in pretty good condition. But rather than just saying pretty good condition, this is an analysis that will help you to say quantitatively what you mean by pretty good condition, as in 2% poor, or some quantitative measure like that, which is what you need for your transportation asset management plan. So the conclusions for the bridge life cycle cost analysis, the methods are pretty mature. At the project level, they've been in use for a very long time, and even at the network level, they've been in use for a great many years. They are sensitive to the quality of data, and so with element level inspection, the states, for the most part, have had really good condition data. They have not so far had very good cost data, but that is something that is changing in a lot of states because of efforts like what Kirby described. Many agencies do have suitable data already and have been able to do some good modeling, particularly of deterioration. Bridge management systems put the work to use in order to take this information and guide day-to-day decision-making about preservation investments and resource allocations that might be made. So you can use the process that Katie described to submit your questions, and I'll be happy to answer them.
Fantastic. Thanks, Paul. I wondered if you could clarify one thing for me. When you were talking about statistical modeling under the model development, you talked about the fact that you need 500 inspection pairs per element or group. And I wondered whether that number varies based on the size of the population, or if there's some sort of a method that you use to calculate that.
Right. It actually it doesn't vary based on the size of the population. It actually is more a description of how big the population needs to be for the modeling to work. You'll get better statistical performance with a bigger population, of course. You would like to be able to do validation of your models, so you'd like to be able to hold aside an additional 500 inspection pairs in order to basically check the validity of the statistical model that you develop with this. But you can get a good model of 500 inspection pairs. What we have to do a lot of times for uncommon elements, for example, there's an element for steel bridge cables. It's hard to pull together 500 inspection pairs because most states just don't have very many cable-supported bridges in their inventory. So you may have to group those elements with other steel elements in order to get a big enough sample size to do an analysis. And that was what we did in the Florida work I described. Actually, we've done that in every state that I've done this kind of work. Is we look at the populations, and if we can't get 500 inspection pairs, then we'll group some elements together so we do have 500 inspection pairs.
All right, thanks. And there was one other question that came in for you. If replacement requires the widening of the bridge to account for new standards or shoulders or so on, how do you account for those costs in the life cycle? And in the meantime, I'll be pulling up Shobna's presentation.
Right, that's a great question, and I don't think anybody has a good network level approach to that, but this is often done at the project level, where you might you might use your traffic forecasting models to try to forecast congestion, and then you might use a user cost model to estimate value of time wasted by commuters in congested roadways, basically looking at the delay caused by lack of roadway capacity. So that kind of analysis has been done for a long time at the project level. But bridge management systems right now don't have a good way to do this at the network level, and so it's a problem. It's probably one of the next great topics for research as agencies get comfortable with AASHTO's new system as far as future enhancements that could be made to that system.
Excellent. And for those of you that have additional questions, this is a great time to ask the experts as to how you go ahead with this life cycle analysis. What we'd like to do now is, now that we have the basics of how to do the life cycle analysis at the network level, we have Shobna Varma, who's the president of Star ISIS Corporation. And she has been very involved in the asset management community, working with agencies to make process improvements in the areas of asset management, risk management, and performance management. She was previously the Chief Information and Technology Officer for the Ohio DOT, and she's going to be sharing with us her recommendations for actually linking the financial plans in your asset management plan with the results of your life cycle analysis. So Shobna, the floor is yours.
Thank you, Katie. Can you hear me?
I can hear you just fine.
All right, thank you. So we had both Paul and Kirby talked in detail about the pavements and the bridges, and what I'm going to share with you today is really how the asset management plan and the financial plan associated with it, the long-term view, really supports a life cycle cost. So that's a big picture that I want to share with you today. So if you recall, Kirby had shown this particular slide, and what this was talking about is the cost associated with life cycle when you think about typical versus desired versus worst first. And so what I'm going to do in the next several slides is really show you what can be achieved in a short-term plan versus what can be achieved in a long-term plan, and how financial planning, the long-term plan provides a really good perspective when you think about life cycle costs. So, this is a slide that Kirby showed, and what this was talking about is, I think about $17 billion, he said, was the cost associated with doing, worst first, and then about $600 million was the cost associated with doing the desired approach. So really, when you think back to what Kirby was showing and also Paul was talking about, is that without life cycle costs, you really are experiencing higher long-term costs. And without this long-term horizons, you really lose the benefits of long-term costs, and they're not obvious. Long-term horizons provided in the asset management plans naturally support a life cycle approach. And so let's take a few examples here, and let's take a look at what this means. This is a slide from one of the DOTs, and I know that most DOTs, when they're looking at long-term perspectives, have something similar for their pavements and their bridges. So this is just one such example. And this example is from the Colorado DOT, and we have used this example in one of the reports that we are developing for Federal Highway, which talks about financial planning for asset management. The point on the slide is that it is showing 5 different investment scenarios, and it's showing the percentage structural deficiency of bridges resulting from this annual 5 different investments. So if you take a look at this slide, what it shows you is that in the very first one, if you look at in the biennial budget, the annual and biennial budget, which is the normal way we do our our budgeting, you can see that really there is not a significant difference between the 5 levels of investment. So if one were to take a look at a biennial budget, the structural deficiency seems almost barely different. And however, when you take a look at a slightly longer term perspective of 5 years, you can see that there is, in this particular example, a slightly more difference between the 5 scenarios. Let me step back for a second and say the very top one that you see, in green, is the perspective based on a $200 million annual budget. And the very bottom one that you see is the one based on a $115 million annual budget. So if you look at the 2013 versus 2018, it's a little bit more obvious that there is some difference between an investment of $200 million versus an investment of $115 million. So as the perspective is getting going over a longer period of time, you can see the difference between the impact of the annual investment. Now, if you take a look at a 10-year horizon, it becomes much more obvious that investing $150 million annually versus investing $200 million has a significant difference. You're almost seeing several points, percentage points difference in your structural deficiency. Extending the same concept, because again we're talking about the long-term perspective. When you reach about 15 years and more, you can see that
the structural deficiency has significantly increased. And when a decision maker or a person looks at this kind of a point of view, they can make out the difference between investing in, in $150 million versus $200 million. So this really shows you that, taking a long-term perspective and planning and projecting a long-term point of view on your assets provides information to decision makers, as well as your ability to communicate with your stakeholders the implications of long-term investment, which is lost when you are working with a shorter-term biennial budget. So taking the same concept, let's just, this is actually a real example from a DOT. We've just changed the years but reflecting the same idea. If you look at the current legislative budget, it's normally you're talking about year or 2 years. And as we saw in the previous example, when you look at a shorter term period of time, shorter term period, it masks the difference. In this particular example, we are looking at 2015 and 2016 pavement budget, and it's about an 8% increase between the first year and the second year, and which looks like a good amount, for when you're looking at a biennial budget. It looks like your budget is increasing, and this gives a perspective to a legislator or somebody else looking at it that there is sufficient money being put into the pavements. However, let's take a look at this. This is obviously a shorter term point of view, which is normally the biennial budgets. Let's take a look at the same information and put it in a longer context, in a bigger context. So what you see here is that the same budget, which was 2015 and 2016, now do not appear to really provide you the same value. You can look at this and you'll see that the 2015 budget is actually significantly lower than some of the other budgets. And then as you start looking at the future budgets, you can see that the budget is dropping. Now, one would not have this perspective if one were just looking at biennial budgets. So that kind of a perspective is lost when you're looking at short-term planning. Let's take the same pavement budget and now add inflation to it. What you see here is that the same 2015 and 27 budgets that we thought appeared to be good enough, or providing us the positive information or the increasing budget, really when you look at it in the context of inflation, it's reducing. It's really not providing us the information that we want. It is not providing us a budget that we want. And you'll see that the 2019 budget, which appeared in the previous slide to be not a bad amount, is really much smaller than even the 1999 budget. So really, when you look at budgets and put them in the context of these longer-term planning scenarios, and you apply inflation and other factors to it, you get to really, understand the longer-term perspective of your budgeting. And this is the kind of information that, if you share, if one shares with one's stakeholders, it, allows them to, it provides them a better context. And it also allows them to understand the seriousness of the need, that you're reducing your budget versus increasing your budget. So, this is also a good way to communicate with the public to really show to them or convey to them that the public's needs are not being met because you're significantly reducing your budget. Taking the same information, if you now put it onto what is it that you can achieve with this information, what it is showing you is that the budget that we saw after inflation, and if you relate it to what you can achieve in your percentage of road conditions, you can see now that the condition of your system is dropping over the 15-year period. Now, by just looking at it in the short term, and we are looking at the 2-year budget, it seems like there was an increase. However, when you put it in the context of inflation, you put it in the context of the long-term plan, you can see that really this budget is not going to achieve, to help achieve the system conditions that you're looking at. So I'm going to show you another example. This is an example of it's an illustrative example of a DOT that we've used in one of our reports on financial planning for the Federal Highway Administration that is pending publication, but it provides you the same idea, the big picture. So I don't expect you to see all the numbers here, but what you'll see big picture-wise, this is showing the needs of an agency, and we are just showing a couple of big-ticket items. Let me take an enlarged view of the same information. So if you look at this view, you see when we're talking about financial plans, there are several components to it. You have the uses, which is the needs, then you have the sources, which is your revenue, and then you start looking at the gaps. This particular table is showing you the uses or the needs as projected for an illustrative state agency. What you'll see, the idea behind this financial planning is that in this particular example is we've taken the asset management strategies of an agency and saying based on good preservation, good maintenance, long-term strategies, we've come up with what would be the overall system condition that this particular illustrative agency can achieve, and that is shown in the first row, in the first row below the header. What you'll also see is that so you're projecting in your asset management plan what is the system conditions you are going to achieve over the 10-year period. You see what the financial plan then does is that based on your asset management long-term strategies, it tells you what you will be projecting, what you are going to, what is the kind of monies that you're going to put into or you need for your pavement rehabilitation, pavement preservation, and pavement maintenance in this particular example. This is a simplified example, but it communicates the idea that agency has a specific target it is trying to achieve, and in order to achieve this target over the long-term period, over the 10-year period, it has specific funding needs that it needs to put together. So you'll see on the top that is the information for pavements, and similarly at the bottom of that same Excel chart, what you're saying is in order to achieve to reduce the structural deficiency or to maintain the structural deficiency shown in the Excel chart and reduce it from 18% systematically over a 10-year period to 12%, we're showing the amount of money that needs to be invested in bridge rehabilitation and bridge maintenance. Now, as a DOT in realistic terms, we'll take similar information and actually show it for its NHS and IHS and non-NHS and into much more granular categories. But the idea behind this is that when you do a long-term strategic TAM asset management plan and you come up with the targets that you want to achieve, you will then estimate what is the kind of monies you're going to put in these different categories, and they'll tell you what is the funds that you would require to achieve those conditions. Now, is this going to be what you will, what the kind of monies that a state will get? May not be, and so that comes to the second aspect of the second slide. What this slide shows is that in the example that in the example that I just showed you, the total needs of that agency to meet all of its asset management needs is about 9 billion plus. Okay. However, the revenue that it is going to get is estimated to be on the line above about 8 billion or so on and so forth. So what does this asset management financial planning allow you to do? It allows you to project what it is that you need to accomplish and the money that is required for that. But then it also allows you, has you in its sources computation to figure out what is the total revenue that you're going to get. When you look at something like this, you have two options, right? So the option one would be then to figure out how you're going to increase your revenues in order to meet your needs. The alternate will obviously be what is it that one will be trading off in order to keep within the budget, right? So we have a gap here of various amounts over the course of different years, and so the agencies can look at it and then say, okay, what is the kind of trade-off between the different programs, and within the different programs it has to do in order to have a fiscally balanced budget for the 10-year period. So So the idea behind, so this is the kind of information that is obviously not, is not obvious when one is doing a 2-year or a short-term budget. Because it seems like, as we saw in the earlier slide, it seemed like the 8% that we were talking about was a good amount of money in order for us to achieve our asset management plans. However, when we put it in perspective, plan out our long-term investments, not just for bridges and payments, because I didn't get into great detail on that, but you will see that in your asset management financial plan, you will have all of those categories, including debt servicing and so on and so forth, which will really be the, your total uses will be captured there. So the big picture point is that what I wanted to share is that as you do your asset management plans and you develop your, taking into consideration your long-term strategies, your 10-year plans, your 20-year investment plans, and you pull it all together and figure out what is the amount of monies that you need, what is the amount of monies that you forecast will be available to you, and the gaps in the funds, you'll start making trade-offs. And so then based on the trade-offs, you really will get a bigger picture view of what it is that you can achieve. And that is the kind of information that when you present it to your legislators or to your stakeholders and others, it gives a better picture of the funding needs and also what kind of system conditions or asset conditions you can achieve with the funds available to you. So that is a big picture. So really what we're trying to show with this financial planning plans associated with asset management and long-term plans is that when you put this kind of an asset management plan and a financial plan, it provides a longer-term life cycle perspective, and these longer horizons are absolutely needed in order to appreciate the life cycle effects of different investment options, as we saw in that $115 million versus $200 million financial option. Similarly, the financial plans will help influence short-term budgets and STIPs because we want to align, and hopefully it will help align these 2-year plans and 4-year plans with a 10-year plan and a 20-year plan, and then really provide a more realistic financial, a picture of the financial health of an agency. So with that, Katie, back to you.
Okay, fantastic. Thank you. I appreciate it. That concludes our formal presentations, and I want to thank Kirby, Paul, and Shobna, each one of them, for our presentations today. I am going to open it up for questions and answers, so please go ahead and enter your questions on the Q&A feature of the webinar toolbar. And I'm going to start things off, Kirby, with a question for you. One of the things that I hear is states asking, how do I get my head around a network level life cycle cost analysis? They're familiar with the terms from a project level, but not so much with a network level. And I'm wondering if you could speak to sort of the challenges that you had to face in trying to approach it from a network perspective, and if you have any advice that you might offer to people that are trying to figure out how to approach this.
Sure, Katie. Thinking about pavements from a network perspective, I think one of the initial conversations that we had as a technical team and as the project management team was to determine whether to aggregate pavements at a network level or to keep them separate, meaning rigid versus flexible. And we ultimately, as we met, the project management team met several times and decided to kind of aggregate the two. And I think that's one of the main challenges that I see that came out of this whole process was trying to aggregate the two. And when you're telling the story to others within the agency that think asset management is important, and you're trying to tell that story or show them the different strategies between desired versus flexible, it's really hard for individuals to differentiate between the two different types when you aggregate them up into one document or one modeling scenario. I think that's one of the main challenges that we had for pavements anyways. again, another one that I wrote down just real quickly was not necessarily, this isn't for payments. I'm actually kind of going off on a tangent here, but identifying different analysis periods for other assets. And maybe Paul can probably speak to this too, but pavements, we have a lot of information on pavements. Condition data, what sort of treatments are happening over the life of a pavement, and the anticipated life cycle or the life of a pavement. But there are other assets that there's not a lot of good information on, and one of the assets that we included was overhead sign structures. And when you look at the research that's out there and determining what the appropriate life cycle analysis period is for that, that was a challenge within our asset management plan. And I had mentioned in my presentation on maintenance data and the limited information that we had at the time when we put together a life cycle cost analysis. And we used 2012 data from the Metro District, and we kind of made some assumptions on weighting it and applying that to certain condition levels. And I think there was a little bit of hesitation or uncertainty that that's occurring at a statewide level. So again, that was another challenge. And then the other challenge that I remember as part of the process for at a network level was to determine, and this is a big conversation that we had during TAMP development as part of the life cycle cost analysis and after with senior leadership, was whether operations actually improves pavement condition and whether to include it in the life cycle cost analysis. And what I mean is pothole patching. We have some maintenance engineers that are real strong towards this idea that mastic patching for pavements really adds value or life to pavements and improves the life cycle cost analysis results. And we decided not to include that in our network life cycle cost analysis. And then there were some discussions on whether to include other elements such as safety or impacts to the users, and we did not include those, and that was definitely a challenge. So I've highlighted several challenges. I don't know if I answered your question.
You did, and you mentioned one of the challenges that we got a question about as you were explaining it. They wondered if you could explain one more time your weighting factors for the maintenance costs, you know, the good, fair, poor weights, and how you decided to allocate the maintenance cost that way.
Boy, let me think back.
Was that primarily based on the mileage that in that?
Yes, it was. So there was 400, without looking at, I don't have my presentation up, but there's 482 lane miles that were preserved in 2012, and the weights were primarily based on the number of lane miles in a certain condition by the number of total lane miles, proportionate to the $1.4 million that was spent on maintenance activities by the total miles. So combination of all of it.
Excellent, thank you. And you can download the presentation if you want to look at the ratios that were used. We have time for one more question for Paul. And the question is, can you explain where your discount rates come from? The participant is saying they're used to talking about 2% discount rates, not 90% or 95% as shown in your slides.
Sure. Yeah, the definitions can get a little confusing as far as the naming of these different kinds of discount factors and discount rates. Yeah, typically the discount rates that you see out there today in transportation management plans are what I've been seeing anyway is typically from around 1.9% to 2.5% or maybe 3%. Those are expressed in the form of interest rates, and in fact, the guidance that agencies often are given by, say, the Office of Management and Budget is to determine those discount rates in part based on the interest rates on federal debt, because that's one sort of industry metric of how much of a discount applies for postponing costs or postponing revenues. The 90% or 95% that I was using is just converting those numbers from an interest rate form to a discount factor form where you're multiplying that number by a future cost in order to come up with the value of that cost if it's postponed for a year. So they're based on the same concepts. They're just mathematically transformed for particular analysis.
Fantastic, thank you. That is all the time we have for our webinar today. So I want to thank Kirby and Paul and Shobna one more time for their presentations, and remind you that our next webinar is going to be part 2 of the network lifecycle cost analysis on September 9th, and we will be showcasing some case studies of how people have used the results of their lifecycle analysis to influence some investment decisions. So thank you again. I look forward to talking with you in 2 months. Thanks very much.